Graphical method of solution of a pair of linear equation. We have already learned that when two lines are given in a plane, then three possibilities can happen. The two lines will intersect at one point. The two lines will not intersect, that is, they are parallel. The two lines will be coincident. Consider this graph. Here, two lines x minus 2y is equal to 0 and 3x plus 4y is equal to 20 intersect at a point, that is 4, 2. This implies this is a common point and it lies on both the lines and a solution of both lines. Since 4, 2 is the only common point on both the lines, there is one and only one solution for this pair of linear equations in two variables. Hence, we can say that the lines may intersect in a single point. In this case, the pair of equations has a unique solution. Now consider another pair of linear equations, that is 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18. From the graph, we observe that every point on the line is a common solution to both the equations. So the equations 2x plus 3y is equal to 9 and 4x plus 6y is equal to 18 have infinitely many solutions. This is so as if we divide the equation 4x plus 6y is equal to 18 by 2, we get 2x plus 3y is equal to 9, which is the same as equation 1. That is, both the equations are equivalent and have same almost all the points common. Hence, we can say that the lines may be coincident. In this case, the equations have infinitely many solutions, dependent, consistent pair of equations. Now, look at this situation. Here we have linear pair of equations 2x plus 4y minus 12 is equal to 0 and x plus 2y minus 4 is equal to 0. The situation is represented geometrically by two parallel lines. Since the lines do not intersect at all, this also means that the equations have no common solution. Hence, we can say that the lines may be parallel. In this case, the equations have no solution, inconsistent pair of equations. Let us consider the three situations again and put them in form A1 by A2, B1 by B2 and C1 by C2 and compare. Putting first pair, we have A1 by A2 is equal to 1 by 3. B1 by B2 is equal to minus 2 by 4 and C1 by C2 is equal to 0 by 20. We can see that A1 by A2 is not equal to B1 by B2. Now considering second pair, we have A1 by A2 is equal to 2 by 4 is equal to 1 by 2. B1 by B2 is equal to 3 by 6 is equal to 1 by 2 and C1 by C2 is equal to 9 by 18 is equal to 1 by 2. Here we can see that A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to 1 by 2. Now consider the third pair. Here A1 by A2 is equal to 1 by 2, B1 by B2 is equal to 2 by 4 is equal to 1 by 2 and C1 by C2 is equal to 4 by 12 is equal to 1 by 3. Here A1 by A2 is equal to B1 by B2 not equal to C1 by C2. We can summarize all three conditions as in the following table. Example: find whether the following pair of equations has no solution, unique solution, or infinitely many solutions. 5x minus 8y plus 1 is equal to 0. 3x minus 24 by 5y plus 3 by 5 is equal to 0. Solution: multiplying equation 3x minus 24y by 5 plus 3 by 5 by 5 by 3, we have 5x minus 8y plus 1 is equal to 0. Now putting in form A1 by A2, B1 by B2, C1 by C2, we get A1 by A2 is equal to 5 by 5 is equal to 1, B1 by B2 is equal to minus 8 by minus 8 is equal to 1, C1 by C2 is equal to 1 by 1 is equal to 1. This implies A1 by A2 is equal to B1 by B2 is equal to C1 by C2 is equal to 1. Implies lines are coincident, hence have infinitely many solutions.